Hi everyone, today we're looking at solving linear equations. Our learning intention for today is by the end of this lesson you will be able to solve a linear inequality. Let's look at the following question. Can you solve this? 2x plus 3 equals 11. Please pause the video and try and solve it. Okay, now that you've paused the video and solved it yourself, let's see if you were right. 2x plus 3 equals 11. To solve for x, we want the x's on the left-hand side and the numbers on the right. To move values across an equal sign, we do the opposite. 2x plus 3 equals 11. When we're solving inequalities, we do it in the exact same way. Let's have a look. Subtracting 3 from both sides leaves us with 2x equals 8, and if it's an inequality, we're left with 2x is less than 8. To solve for x now, we divide both sides by the value attached to the x. So we divide both sides by 2. This leaves us with x is equal to 4. If it's an inequality, we do the exact same thing. Dividing both sides by 2, we're left with x is less than 4. When you're solving inequalities, do them in the exact same way you use your equal signs. We'll have one extra rule further on. Let's look at an example question. Solve the inequality 3x minus 5 is greater than 7. To find x on its own, we want the x's on the left-hand side and the numbers on the right-hand side. Let's add 5 to both sides. We're left with 3x is greater than 12. We now divide both sides by a value attached to the x, i.e. divide both sides by 3. This leaves us with x is greater than 4. And we're told that x is a natural number. This means that x can only be a whole number that is positive and greater than 0. This is the solution set of the inequality. Let's look at another one. 3x plus 8 is less than or equal to x minus 4, where x is an integer. An integer means that x will be a whole number, but it can be positive or negative. Okay, to solve this equation, we want to bring the x's to the left and the numbers to the right. Let's move our x's first. So I need to move this x that is on the right. To do that, I'll subtract x from both sides. These cancel and we're left with 3x's minus 1x gives me 2x's. Bringing down our remainder, we have plus 8 is less than or equal to minus 4. Remember, we want the x's on the left and the numbers on the right. Let's move our numbers to the right-hand side. To do this, I'm going to subtract 8 from both sides. This leaves me with 2x is less than or equal to minus 4 minus 8, which gives us minus 12. To find x on its own now, we're going to divide both sides by 2. This leaves us with x is less than or equal to minus 12 divided by 2, which gives us x is less than or equal to minus 6. Let's show this value on a number line. X is any value that is less than or equal to minus 6, but we're also told that x is an integer. This means that x can only be a whole number. So our range of x's are minus 6, minus 7, minus 8, and then we show an arrow to show that this value continues. Please pause and take down this example. Let's look at when we have to solve linear inequalities when the x term is negative. Be careful with negatives. When you multiply or divide an inequality by a negative number, the inequality sign will swap around. The same thing actually happens with equal signs, only it makes no difference. So if you have to divide by a minus number, you need to flip your inequality. Let's have a look at an example. Solve 5 minus 4x is less than 9, where x is a real number, and show the solution set in a number line. If x is a real number, it means that x can be positive, negative, whole, or decimals. To solve for x, we want the x's on the left-hand side and the numbers on the right-hand side. The first thing I need to do here is add 5. Is subtract 5 from both sides. Okay, so subtracting 5 from both sides, we're left with minus 4x is less than 9 minus 5, which gives us minus 4x is less than 4. We now want to solve for x, so we're going to divide both sides by minus 4. When dividing by a minus, you must flip your inequality. This leaves us with x is greater than 4 divided by 4, which gives us x is greater than 1. Let's show this on a number line. Remember that x is an element of a real number, which means that x can be positive, negative, or it can be a decimal or whole number. To show x is greater than 1, we go to 1 on our number line, draw an open circle because our value is greater than 1, sorry guys, we should have a minus in there. So x is greater than minus 1. So draw an open circle at minus 1 and draw a line showing that our value is any number greater than minus 1. Let's try another example. 13 minus 3x is greater than 7. The first thing we need to do here is subtract 13 from both sides. This leaves us with minus 3x is greater than 7 minus 13, which gives us minus 6. To solve for x now, we must divide both sides by minus 3. If you're dividing by a minus number, you must flip your inequality. This leaves us with x is less than minus 6 divided by minus 3 gives me 2. So x is less than 2. Please pause and take down this example.